Hello friends, welcome to my YouTube channel. So today we are going to pick a chapter from class 10 physics. So today we will study current electricity. So let's start. We have current electricity. So first let us know what is electric current. You in your previous classes may have realized that current is nothing but flow of electrons. Flow. This is ultimately current. But only saying that current is flow of electrons will not clear our concept. Because there is something called rate of flow. Now, does rate matters? Question is that. Is rate so significant that we need to take in account rate? The answer is yes. Because you see, suppose flow of electrons means we know flow of charges. So, suppose 10 coulomb of charge is flowing in case 1 and in 10 coulomb of charges is also flowing in case 2. But here 10 coulomb is flowing through a time interval of 10 seconds and here a time interval of 100 seconds. Then here current will be, you see, 0.1 coulomb, ampere, and here current will be 1 ampere. So this is the huge difference that comes in current because the time interval is different. So by saying only flow of electrons will not be the appropriate one. In fact, we should say current is rate of flow of electrons. This is correct because when you take into account time and different time intervals will give us different current for the same amount of charge flow. Did you get my point? So you may note it down that current is nothing but rate of flow of electrons. Here electrons actually mean charges because we know electron carries charges. Next point is there any direction of current? Let us analyze. Yes, the answer is yes, there is a particular direction of current. Let us see how. Suppose in a conductor, first of all, flow of electron only occurs when there is free electrons and the free electrons can move in a conductor. So all the materials which will have free electrons, not electrons that are bonded to an atom. Bonded electrons does not conduct electricity. So the electrons which are free will move. Let us suppose this is a conductor and electrons are flowing this way. Let this be the motion of electron. Then we take the direction of current to be opposite of that. Current will flow in this way. Means direction of current is opposite to the flow of electron. If in a coordinate system current electrons is flowing towards plus x-axis, then current will flow towards minus x-axis. Just opposite. Simple. So this is what the basic definition of current. Now I am going to tell you something different that is not in your syllabus, but it is very important that we define some quantities as vector quantities and some as scalar quantities. We will study this in your higher classes like class 11. Let me tell you, vector is something which have direction and magnitude. For example, you may take many things like force is vector quantity because force has direction also and magnitude. And scalar are the quantities which have only magnitude but no direction. Now, how will you classify current? Let us understand. First of all, current is a quantity which has direction. Just now we have seen. So you may say that it is a vector quantity, but actually it is not. And interestingly, neither it is also a scalar quantity. For current, we term another quantity that is tensor quantity, T-E-N-S-O-R. This type of quantity. You will study this in your higher classes, what are tensor quantities. But for your understanding, I can say you that it is not a vector because something is called vector loss. Vector loss, which are followed by all the vector quantities, but current does not follow vector loss. You will study in your higher classes. So it is not a vector quantity. Mind it, it is a tensor quantity. It is not asked generally in board exams, but you will get such type of questions in your OLYMPAIDS and other competitive exams that you give. Question will be asked. Current is dash quantity. And your options will be A, scalar, B, vector, C, tensor, D, let us suppose none. Then you should not answer B as vector. It will be wrong. It is a tensor quantity. This is correct. Mind it. So let's move ahead. Next we shall study how does current flow in a circuit. So when we come to this question, my first answer will be current flows because of potential difference. So let's understand what is potential difference. Potential difference. Potential difference. What is it? It is denoted by V. Find it. So please pay attention. Potential difference between 2 points is the work done to carry a charge from this point to this. Suppose this is A, this is B. So potential difference between A and B will be work done to carry a unit charge, means charge from point A to B. How we define it? This is the mathematical relation V equal to W by Q, and when Q equal to 1, V equal to W. So potential difference is the work done to carry a unit charge, because we have taken Q equal to 1 from one point to the other, and the potential we get is the potential difference between that 2 points. And current flows because of the potential difference between the battery in a circuit. We see in a battery we draw one terminal as small and one terminal as large. The smaller terminal is negative and the larger terminal is positive, obviously. So this is in lower potential and this is in higher potential. Means there is a potential difference. Who creates it? It is because of the chemical reactions happening inside the battery. This chemical reaction stimulates a sense of potential difference between the two terminals of the battery, and as a result there will be a potential difference V will be created, and so current will start flowing. Because just now I have told that for current to flow we obviously need potential difference. Mind it. So now in a circuit, let us suppose this to be a circuit. Here, suppose this is a bulb, and suppose this is some sort of resistance. Will come in our next discussions. In this circuit, if this bulb has to constantly glow, then there should be a constant source of current through the circuit. Means the current should be applied for a longer period of time, so that the bulb also glows for a longer period of time. Means this battery has to generate potential difference constantly, and for this battery has to create chemical reactions, or you can say this battery will stimulate chemical reactions constantly to create a constant potential difference. In other words, it will expand its chemical energy, and as a result, when all the chemical energy will be exhausted, the battery will stop working, as we have seen in our remotes or different type of gadgets where we use battery. After some days we have to replace the battery. Why is it so? Because when our battery stops working, you have to understand that the potential difference between these two terminals becomes zero, and the battery cannot further stimulate chemical reactions to create a potential difference, because it has spent its chemical energy. Now its chemical energy is zero. So how can it further create a potential difference? So exactly this happens when our remote stops working, or any other gadget that is based upon battery. So now we have understood what is potential difference and what is electric current, and we have found two formulas. What are those formulas? Let me summarize what we have studied. See, we have studied I is actually rate of current. Current is actually rate of flow of charge, means charge by time. This is the first formula of this chapter. Next we have studied what is potential difference, V. It is nothing but work done to take a charge from one point to another. So far we have studied these two formulas. Now let me discuss what is the relation between potential difference and current. See friends, potential difference is directly proportional to current. This means that the more you apply the potential difference, the more current will flow in the circuit. Or inversely, you can say if the potential difference across two terminals of the battery is less, then current in the circuit will be less. So this is the relation, and from this relation, what we can write? Suppose this is the relation. So to remove the proportionality sign, we introduce a proportionality constant, that is R. So here it comes the third formula, V equal to IR. What is R here? It is a proportionality constant, and it is known as resistance of the circuit. Now We will discuss about resistance in our next classes. But what is this? V equal to IR. This is nothing but the Ohm's law. This is known as Ohm's law. We will discuss about Ohm's law in details in our next classes. Today we should end up here. But remember, we have got our third formula of this chapter, which is V equal to IR. Please mind it. So thank you friends for today. We have studied 3 major formulas. Study the chapter. We will meet soon in our next classes. Thank you.